A single photon takes 100,000 years to escape the sun's core, bouncing atom to atom in a furnace of crushed light. But that is nothing compared to what waits at the edge of everything we understand. A dark nebula can swallow a light source so completely that entire star systems behind it simply vanish from the sky. Bok globules are cold clouds of gas and dust, so dense that no light escapes them at all. Barnard 68 is one of these clouds, sitting about 500 light-years away, blotting out the stars behind it like a hole punched into the night. If you flew toward it, the stars would not dim gradually. They would disappear one by one, as if the universe were being erased in front of you. But the next object on this list does not just block light. It refuses to reflect any at all. TRES 2b is a planet orbiting a distant star, and it reflects less than 1% of the light that hits it. It is darker than coal, darker than fresh asphalt, darker than anything on Earth. Scientists believe its atmosphere contains light-absorbing chemicals like vaporized sodium and titanium oxide, heated by a star so close that the planet's dayside can reach over 1,000 degrees Celsius. Imagine a world so hot and so black that it looks like a smudge of ash floating in front of its own sun. But heat and darkness are only the beginning. The next kind of darkness does not come from a lack of light. It comes from light being trapped. A black hole does not simply absorb light. It bends space itself until light has nowhere left to go. Cygnus X1 was one of the first black holes ever confirmed, discovered through X-ray emissions in the 1970s, and it holds about 21 times the mass of our Sun, crushed into a region only a few dozen kilometers wide. If you got close enough, gravity would stretch your body from head to toe, a process scientists call spaghettification. Your feet would feel a pull thousands of times stronger than your head. No warning, no light, no escape. But even Cygnus X1 is a lightweight compared to what comes next. At the center of our galaxy lies Sagittarius A star, a black hole with a mass about 4 million times that of our Sun. In 2022, astronomers finally captured its image, a faint ring of light bending around absolute nothingness, 26,000 light-years away. Despite that staggering mass, from Earth, it appears smaller than a tennis ball would look, sitting on the surface of the Moon. It sits quietly at the heart of the Milky Way, like a lion sleeping in the center of everything, patient and ancient and utterly indifferent to us. If you have made it this far into the darkest corners of the universe, drop a like and subscribe, because the next black hole makes Sagittarius A star look small. TON 618 is an ultramassive black hole, with a mass estimated at 66 billion times that of our Sun. It could swallow our entire solar system out to Pluto without noticing a change in its appetite. Light from matter falling into it takes months just to cross the region we call its shadow. No star could survive getting close. No planet would leave a trace. But mass is not the only way an object becomes dark. Some black holes vanish entirely from view, not because they are far away, but because they are alone. Rogue black holes drift through the galaxy with no companion star to illuminate them, completely invisible against the black backdrop of space. In 2022, astronomers detected one for the first time using a technique called gravitational microlensing, watching it bend light from a background star as it passed in front, roughly 5,000 light-years from Earth. There could be millions of these wandering unseen through our galaxy right now. One could drift through our solar system, and we might never notice until it was already too late. But what happens when an object becomes so dense that even the rules of physics start to break down? A neutron star is what remains after a massive star collapses, and it packs more mass than our Sun into a sphere only about 20 kilometers wide. A single sugar cube of neutron star material would weigh about 1 billion tons on Earth. If you stood on its surface, gravity would be so extreme that your body would be crushed flatter than paper in an instant. Some neutron stars spin hundreds of times per second, and some, called magnetars, generate magnetic fields trillions of times stronger than Earth's. SGR 1806-20 is one such magnetar, and a starquake on its surface in 2004 released more energy in a fraction of a second than our Sun produces in 100,000 years. If a magnetar were within 1,000 kilometers of you, its magnetic field could rearrange the atoms in your body before you even registered pain. But even magnetars pale next to what lives beyond the reach of light entirely. Somewhere in the dark spaces between galaxies, dark matter makes up about 27% of the universe, and we have never directly seen it, only felt its gravitational fingerprints on galaxies that spin faster than they should. Without it, galaxies would fly apart, stars would scatter like leaves in a storm, and the structure of the cosmos as we know it would never have formed. Its darkness is not the absence of light. It is the absence of any way to detect it at all. And this is where things become strange. Beyond dark matter lies dark energy, an unexplained force making up roughly 68% of the universe, and it is accelerating the expansion of everything, pushing galaxies apart faster over time instead of slowing them down. We do not know what it is. We only know it is winning. Eventually, in trillions of years, distant galaxies could be pushed away so fast that their light will never reach us again, leaving our night sky permanently, silently empty. But even this is not the final darkness on our list. Physicists theorize about something called a naked singularity, a point of infinite density with no event horizon to hide it, something that would break the laws of physics as we understand them, if it ever existed. We have never confirmed one exists, but the mathematics does not rule it out. If it did exist, it would be a wound in reality itself, a place where prediction fails and cause and effect come apart at the seams. And finally, there is the darkest possibility of all, one that does not exist in any single location, but everywhere at once. Some physicists believe our universe may be sitting in a false vacuum, a falsely stable state that could one day collapse into a lower energy state called vacuum decay. If it began anywhere in the universe, a bubble of true vacuum would expand at nearly the speed of light in every direction. There would be no warning. No light would arrive before the wave itself. The laws of physics inside that bubble could be completely different, incompatible with atoms, stars, or life as we know it. It could already be happening somewhere unimaginably far away, and we would have no way of knowing until the moment it reached us. No stars, no warning, no chance to look up. If you are not ready to leave the dark corners of the universe just yet, there is an entire playlist waiting for you, filled with black holes, dying stars, and theories that will make you question the ground beneath your feet. Subscribe before the universe ends, and I will see you out there in the dark.